So, do you see my screen?
Yes, we can see your screen. You can start.
Okay, so today I will talk about our results in one project where we are working with one of our national museums, and the talk is called Advancements in Dating Updated Manuscripts through Dual Methodologies. And let us talk what are dual methodologies. And here is Razwan came. So our goal is to date the handwritten materials of one of our very famous writer, Galaction Tabitze. He is the poet of 20th century. He has a lot of writings, and we don't know. They belong to each year. So, as I told you, we are working together with a museum, and they are using more historical manual approaches, and my team is using machine learning-based approaches. I will talk shortly about the approach and our approach. So the manual approach involves the analysis of letter pairs. They analyze the interconnections between the letters, and afterward we present a template which is created with a special tables which encompass 33 letters of Georgian alphabet. And we catalog them into 561 tied letter pairs, which are in manuscripts, which contains the year from 1907 to 1959. And this is more or less traditional method. And of course, it faces challenges of scalability. It's not efficient. So what is the most challenging problem? So without writing, without lifting a pen and tying letters to each other causes specific changes in the grapheme forms. So in this case, split them, and we can't get the same force of that those graphemes would have if we write them separately. And so we decided not to extract them, but to study them as a whole unit. Therefore, we have created a template with a special table, so of course, of 33 letters of Georgian alphabet, and this particular Tabitze's manuscript is observed by us and relieved, and we revealed 561 such pairs. You can see how they look. This is example of 1914. And during our research for now, we have analyzed 130 handwritten documents from the year 1907 to 1959, what we had, and we created a database of the graphematic unit. If we had typed several letters, we grouped them using the following way: first two, second and third, third and fourth, and so on. So you can see how this looks. Of course, it's Georgian. It can look strange for you, but it is the idea. Afterwards, we encoded them using the codes and got something like this. And of course, as I told you, this approach is well scalable and less efficient. So we began to work creating a special machine learning based program to automatically date manuscripts. So um, we have followed a systematic process. We created model, we trained the model, and we use the model of image recognition. To enhance the producibility of our model, we of course introduced the augmentation techniques because it was always overfitted. And the best, what worked for us, we tried a lot of augmentation techniques, but flipping images horizontally and vertically worked the best. And we divided our data set into 75% for training and 25 for validation. For constructing the neural network, we used Python, of course, in Google Colab. We used TensorFlow and Keras libraries, and we created layered architecture where we mimic the brain ability to recognize features like shapes, colors, patterns, and so on. I also want to emphasize that we deleted the backgrounds, not to interrupt us. So we had the following steps: data preparation. We had a label data set comprising images of handwritten manuscripts from different years. So we apply data augmentation techniques about which I talked to you already. We created a model, CNN, convolutional network neural model, using TensorFlow and Keras libraries. We evaluated the model using unseen images. What we did afterwards, of course, we saved the model in order to check it on other patterns. And for validation and comparison, we check the accuracy and effectiveness of both manual and automated approach. So we measured the accuracy, precision, F1 score, and etc. We have done the experiments. We gave these images, and here you can see the correct year and the predicted year. If to summarize, we gave it 29 titles, and firstly, the model performed well in predicting the correct year at the top choice for a subset of titles in 17.2%. The second, on the second place, it found in 6.9%, and this, on the third place, it found on 24.1%. It's not bad result when we compare to other researches. And we want to remark that the big portion of the predictions fell within plus minus 3 year range. The number is approximately 48.3. And our accuracy, which I didn't mention during our presentation, we had 71%, which very high for such types of researches. Here is